Right now, water managers at the Bureau of Reclamation are watching one number more closely than almost anything else in the American Southwest: 3,526 feet. That's where Lake Powell's surface sits this summer, just 36 feet above the elevation where Glen Canyon Dam's turbines stopped turning and dropping by nearly 2 feet a month. For 20 years, the story behind that number has been simple: not enough snow, too much heat. A drought that tree rings say is the worst the Southwest has endured in more than 1,200 years. Then, this spring, something changed. Forecasters started reaching for a word they don't use lightly: super. A super El Niño, they said, one that could rank among the strongest ever measured, was building in the Pacific. For a river system that has been losing this fight for 2 decades, that sounded like the cavalry arriving. Bigger snowpack, wetter winters, a reservoir that finally climbs instead of falls. Except cavalry doesn't always show up where you called it. 9,000 miles away, the exact same weather pattern that engineers here are hoping will save Lake Powell had already torn through someone else's power grid months earlier. Same phenomenon, same year, the opposite result. So which is it? Is this Super El Niño the rescue the Colorado River has been waiting for, or a gamble the West is about to lose? To understand why nobody tracking this event, not even the scientists watching it hour by hour, can promise you an answer, you first have to understand what's actually at stake if the coin lands wrong, and what El Niño really is underneath the headlines. Start with the river itself, because the stakes here are not abstract. The Colorado River runs roughly 1,450 miles from the Rocky Mountains down to the Gulf of California, split into an upper basin and a lower basin spanning 7 states. It irrigates more than 5 million acres of farmland and supplies water to something like 40 million people from Denver to Los Angeles. Along its length sit Lake Powell and Lake Mead, the first and second largest reservoirs in the entire United States, both built to catch the wet years and ration them out through the dry ones. That system was designed in the 1950s and 60s around one core assumption: that the water rights promised to those 7 states in 1922 reflected how much the river usually carries. It was a bad bet from the start, struck during a handful of unusually wet years that made the Colorado look more generous than it actually is. Glen Canyon Dam, a 710-foot wall of concrete wedged into the canyon on the Utah-Arizona border, was finished in 1963 specifically to manage that gap, storing floodwater behind it to smooth out the droughts. As water leaves the lake, it drops through turbines and generates close to 5 billion kilowatt-hours of electricity a year, enough to power nearly 500,000 homes across 7 states. But there's a hard floor to that arrangement. The turbine intakes sit at an elevation of 3,490 feet. Engineers call it minimum power pool. Drop below it, and the intakes start pulling in air instead of water, and the power stops. That's why 36 feet is the number everyone is staring at. It isn't an abstract drought statistic. It's the last buffer between the dam works and the dam goes dark. For years, the trend on that number pointed one direction: down. Then this spring, for the first time in a long time, there was a real reason to hope it might reverse. To understand why, you need to know what El Niño actually is, because it isn't a storm, and it isn't something that happens in the sky at all. It's a shift in the temperature of an ocean. Roughly every 2 to 7 years, the surface waters of the tropical Pacific swing between warmer and cooler phases, a cycle scientists call the El Niño Southern Oscillation. During an El Niño phase, the trade winds that normally push warm surface water west, toward Asia, weaken. That warm water sloshes back east instead, piling up off the coast of the Americas. And warm ocean water reorganizes the air sitting above it. It drags the Pacific jet stream, the river of wind that steers winter storms around the globe, south of where it usually sits. Picture the jet stream as a garden hose on an automatic timer, watering roughly the same strip of a very large lawn every winter. El Niño doesn't switch the hose off. It tugs the hose south. For the American Southwest, that tug has historically been good news. El Niño typically favors above-normal precipitation across the Southwest during the winter, Brad Pugh, a meteorologist at NOAA's Climate Prediction Center, explained. Historically, snowfall tends to be above normal across Arizona, New Mexico, southeastern Utah, and southwestern Colorado during El Niño winters. That's the mechanism the entire hope is built on. More snow piling up in the Rockies. More meltwater running into the river each spring. A reservoir that stops falling and starts climbing for the first time in years. But a garden hose on a timer only waters the same strip of lawn if nothing nudges the timer itself. And this year, there's a second variable layered on top of El Niño that nobody can fully pin down yet, which is exactly how far that hose actually gets tugged. Here's what's already confirmed, on the record, by the agency that tracks this for a living. As of this month, NOAA's Climate Prediction Center has El Niño officially active, with sea surface temperatures across the central and eastern Pacific running about 1.2 degrees Celsius above average. All 24 of the forecasting models NOAA consults, 15 dynamical models and 9 statistical ones, agree this El Niño keeps strengthening through the rest of 2026 and holds on into early 2027. NOAA now puts the odds at 81% that it becomes what forecasters classify as very strong by the October to December window, which would place it among the largest El Niño events in the historical record going back to 1950. On paper, that should be unambiguous good news for the Colorado River Basin. AccuWeather meteorologist Chad Merrill told Newsweek the incoming El Niño should be beneficial for the drought, a pattern that will start chipping away at the deficit this summer and keep working through the winter. He also pointed to a second, lesser-known factor stacking the deck further in the basin's favor this year: unusually warm water stretching all the way from Baja California to Hawaii, a pattern called the Pacific Meridional Mode, which can push El Niño's moisture further inland than usual. This pattern helps give El Niño a boost in precipitation for the Colorado River Basin, Merrill said. So far, that's the confirmed, documented case for hope. Now here's the confirmed, documented case for doubt, from the same experts making the optimistic argument. Merrill was careful to flag exactly what could break the forecast: the precise position of the jet stream itself. If it's farther north than a typical El Niño, then the Colorado River Basin would not benefit as much from rain and snowfall, he said. It's too early to draw any conclusions about the orientation of the jet stream, though. In other words, the same El Niño that historically drags the jet stream south over Arizona and New Mexico can, in some years, park too far north to matter here at all, and right now nobody tracking this event can tell you, on the record, which way it lands. Even in the best-case version of this story, the math is brutal. Erasing the Colorado River Basin's accumulated drought deficit would take somewhere between 15 and 25 inches of rain and melted snow over the course of a year. Average winter precipitation across the basin is only 2 to 5 inches. Even a strong, well-aimed El Niño winter would need to be followed by a wet spring, and possibly a wet summer after that, just to close the gap completely. A good season chips away at the drought. It doesn't erase it. That's the story unfolding on this side of the Pacific, a coin still spinning in the air that could land in the basin's favor if a stack of atmospheric variables cooperates. But El Niño doesn't deal one hand at a time. It deals a hand to the entire planet simultaneously. And on the other side of the ocean, the same event has already finished dealing its cards, months ago. In July 2026, Bloomberg reported that India's hydropower generation had fallen almost 21% compared to the year before, as an El Niño-linked dry spell drained the reservoirs feeding the country's dams and put real strain on the national grid. It's the same climate cycle, the same calendar year, the same basic mechanism: a shift in Pacific Ocean temperature reorganizing rainfall thousands of miles away. But in India, El Niño doesn't push the jet stream toward more rain. It tends to weaken the monsoon, the seasonal rains that are supposed to refill the subcontinent's reservoirs every summer. Less monsoon rain means less water behind the dams, which means less hydropower, which means a grid straining to cover demand it can no longer fully generate on its own. Put the two stories side by side, and the pattern is impossible to miss. Same phenomenon, same year. Two water systems on opposite sides of the globe, both leaning on hydropower for millions of people, both waiting to see what El Niño does to their rainfall. One is hoping to be rescued. The other has already been hit. And until this season plays out in full, engineers on the Colorado River cannot rule out ending up on India's side of that ledger instead of the one they're praying for. which is the uncomfortable part of betting a water system that serves 40 million people on a single climate pattern. The same event that rescues one dam can sink another, and right now, nobody controls which outcome the Colorado River actually gets. Zoom out, and the stakes on this side of the Pacific are just as large as the ones already realized in India. Losing power at Glen Canyon Dam wouldn't just be a statistic. It would mean close to 500,000 homes across 7 states losing cheap hydropower overnight. Downstream, Newsweek has reported that Lake Mead, the reservoir behind Hoover Dam, could fall as much as 20 feet below its own record low, a decline that would cut Hoover's hydropower output by roughly 40%, straining power supplies for cities including Las Vegas, Phoenix, and Los Angeles. And it's not only the power at risk. Below Glen Canyon Dam's turbines sits the last resort plumbing, a set of emergency river outlet pipes meant to keep water flowing downstream even after the turbines go dark. Engineers tested those pipes in 2023, while the lake was already dangerously low, and found cavitation damage inside the steel, the same violent, imploding bubble force that very nearly destroyed the dam's spillways during the flood of 1983. Crews have since coated the pipes in a protective epoxy. It's a patch, not a cure. The Bureau of Reclamation has publicly called this the dam's existential moment, language federal engineers do not reach for casually. A full government study of permanent fixes, new bypass tunnels, a rebuilt internal plumbing system, isn't even expected to be finished before the end of this year. And the 7 states that share the river still haven't agreed on who gives up water under the century-old agreement that promised more of it than the Colorado actually carries in an average year. This is the backdrop El Niño is walking into, not a river system with room to absorb a merely disappointing winter. A river system already down to its last buffers, where the difference between a good rainy season and an average one could decide whether Glen Canyon Dam keeps generating power at all over the coming year. For 60 years, engineers treated the Colorado River as a machine they could tune, a problem they could pour concrete at and solve. Right now, the most powerful lever left standing between the river and its own worst-case scenario isn't in their hands at all. You can build a dam to hold a river back. You can't build one that tells the ocean which way to blow. Somewhere in the Pacific right now, a few degrees of water temperature are deciding the fate of 2 water systems on opposite sides of the planet, and by the time anyone can confirm which way it broke, the season that mattered will already be over.